A number is chosen at random from the integers 1 to 10. Find the probability that the number is prime, the number is a multiple of 2, then either prime or a multiple of 2. And the B part of the question says, a number is selected at random from each of the set 2, 3, 4 and 1, 3, 5. What is the probability that the sum of the two numbers will be less than 7 but greater than? Yeah, let's make some room on the board. The first one, it says a number is chosen at random from the integers 1 to 10. Integers are whole numbers. So the same sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now the question says, find the probability that the number is prime. How many of these numbers are prime? 2 is prime, 3 is prime, 5 is prime, 7 is prime. Therefore, the probability that a number chosen at random is prime will be the number of prime in this sample space divided by the total number in this sample space. So let's count how many prime do we have here? 1, 2, 3, 4. 4 over the total number in the sample space is 10. Reducing the fraction, 2 in 4 is 2, and 2 in 10 is 5. Then the second question says a multiple of 2. Multiple of 2, when you multiply 2 by something, the result is called multiple, the number. So 2 times 1 is 2. So 2 itself is a multiple of 2. 2 times 2 is 4. 4 is a multiple of 2. And 2 times 3 is 6. 6 is a multiple of 2. 2 times 4 is 8. 8 is a multiple of 2. And 2 times 5 is 10. So 10 is a multiple of 2. So how many do we have altogether? Let's circle it. 1, 2, 3, 4, and 5. Therefore, the probability that a number picked as random from this sample space is a multiple of 2 will be the number of multiples of 2 there divided by the total number. Multiples of 2, 1, 2, 3, 4, 5. That is 5 over 10, which is 1 over 2. And then question 3, either prime or a multiple of 2. We already have the probability of prime here, and now we have the probability of multiple of 2. Either or, that is what? An indication of mutually exclusive event. So we add the probability. The probability of either prime or multiple of 2 is equal to, let me use the one that has not been reduced. So 4 over 10 plus 5 over 10. The denominators are the same, so we can add the numerator. 4 plus 5 is 9, 9 over 10. Okay, that's answer question A. Question B says, a number is selected at random from each of the sets 2, 3, 4 and 1, 3, 5. What is the probability that the sum of the two numbers will be less than 7 but greater than 3? Questions like this that borders on two sample spaces are better answered using a table. So I'm going to draw a table now. One side of the table will contain one of the sets, the other will contain the other set. So the first set is the element of 2, 3, 4. I'll write that on a horizontal line, 2, 3, and 4. So the other one, I'll write it in a vertical column. The element are 1, 3, 5. And the question borders on what? The sum of the numbers. So I will put a plus here. So we are going to add, I'm using double line to separate the sample space from the result of our experiment. And this is 2 here. So if we throw, or if we pick the first set of numbers, it could be that we pick a 1 from this set and a 2 from this set, such that the result of the experiment will be 1 plus 2, which is 3. It could be that we pick a 1 from this set and a 3 from this set. Therefore, the result will be 1 plus 3, which is 4. And then it could be that we pick a 1 from this set and a 4 from the other set. So the result will be 1 plus 4, which is 5. Why am I adding? Because the question says, what is the probability that the sum of the two numbers, that is after picking the numbers, you are picking from the set. Any of the numbers you pick from either of the sets, you add them together. That is what I'm doing. So 3 plus 2 here will be 5, and 3 plus 3 here will be 6, and 3 plus 4 here will be 7, 5 plus 2, 7, 5 plus 3, 8, and 5 plus 4, 9. The question says, what is the probability that the sum of the two numbers will be less than 7 but greater than 3. This is our result separated with double lines, or these painted lines. All of these, which of this number is less than 7 but greater than 3? Let's circle them. 4 belong there, 5 belong there, another 5 is here, another one is here. So how many do we have altogether? 1, 2, 3, 4. Therefore, the probability that the sum is less than 7 but greater than 3. Let me use symbol. Okay. We have 1, 2, 3, 4. 4 divided by the total sample space. The total sample space, we count everything. 1, 2, 3, 4, 5, 6, 7, 8, 9. Divided by 9. You can see that I didn't count this. These are elements of the set. That is the essence of using bold line here to separate the element of the set from the sample space. So the result is 4/9.